Hi everybody, it's been a while since I've ran into a board that looks like this one does, but the last time that I ran into a board like this, I promised myself the next time that I would record a video. Let me show you what this thing looks like. Here is the housing. As you can see, it is pretty much absolutely spotless. It's a very good housing. You can tell it's never been underwater. Whoever had this has taken really good care of it. There's not hardly any scratches on it. There's no dents. I'm trying my best to keep it in focus for you, but there is no dings. The camera lens is even completely entirely scratch-free. There's not a blemish on this phone. I mean, it looks completely immaculate. No problems here, right? Okay, let's have a look at the logic board. Here we are under the top sticker. Now, just to show you, here's the bottom sticker. It's got some normal... The bottom sticker, it's got some normal dents and dings. Oh, come on, focus, please. But there's no obvious signs of liquid here. There is a little... I mean, keep in mind, I'm under a microscope, so these tiny little specks that you see on here, this is not liquid damage. The top sticker, whenever I peeled it away, it looked completely and totally spotless, and it peeled away just perfectly. This board doesn't have the look of a board that has been worked on before. The stickers look perfectly. This looks like I'm the first one to touch it. Now, the last time that I ran into a board like this, as you can see, I mean, look at these caps along here. We've got stuff corroded. This is disgusting. And I'm pretty well certain that this is a board that has not been worked on yet by independent repair. It's not a board, if we look at the top side, it has the original foam padding intact around the connectors. It has the liquid damage indicator is not tripped. Everything about this board looks unscrewed with. I mean, it's a decent looking iPhone 7 board until you peel the stickers off, and then it looks like this. Now, we've got capacitors here that are really corroded, guys. I mean, look. Try my best to keep the microscope still for you, but this looks really bad. It looks like it's been in salt water or something. Now, I imagine this corrosion here, this could be from flux that's on the board. Now, the last one that I ran into, I haven't touched this one yet with a blade, but if you look at this stuff between these chips, it sort of flakes away. This stuff here, it kind of breaks, and there's pits and holes. Let's see if I can find a better example. Yeah, down in here. Let's get right down in next to the PMIC. This is not your ordinary underfill. It's like maybe the underfill is a two-part thing and this isn't completely cured right, or maybe this is different stuff altogether. I don't really know what the difference is in this. I mean, this isn't the typical underfill you see. Watch what happens whenever I touch this stuff with a blade. It'll tend to like break and huge chunks of it'll come out. And I have seen this on these boards before. I think, I don't know, maybe the machine that squirts out the underfill was having an issue, and then like there's two bags of stuff or something and they didn't completely mix right. I don't know what this process is like, but this is not your standard iPhone 7 board that you see that's got the underfill all pretty even and black and hard. And this one here is pretty nasty, and it could be the chemicals that are on the board that have contributed to this corrosion on these caps. But I don't know, you tell me, is Apple using liquid damaged boards in refurbished phones? This looks really liquid damaged, guys. What is this? PMIC, I mean, this looks really grungy. It's got the look of a phone that's been wet. Now, I haven't been at this with a Q-tip yet, and as you can see, we've got some sort of fibers down in here. I don't really know what this is. It almost looks like a board that's been apart in a workshop and sat apart for a long time and let like dust settle on it or something. I mean, I really don't know. There seems to be a lot of corrosion here, and even down in, maybe this is just stuff. Anyway, let's not nitpick this too much. This logic board is not powering on due to a VDD main short, and I have already applied current to the board, and I've decided that the short is going to be down here in the lower portion of the board because it got hot and burned my fingers. So I believe this is going to be where the short's at. Now, to check for this VDD main short, I hooked my ground up to it, and then I applied 4 volts right here to this side of these 2 caps, and whenever I did that, that is whenever I felt heat down here at this under this bottom sticker. So let's fix the board, shall we? All right, I'm gonna put you back under the microscope here, and we're gonna peel off this bottom sticker. Now this is a repair that I've probably got a dozen or a couple dozen videos on, so there's not going to be anything new here, except for the fact that I believe that this is a liquid damage board, maybe, possibly. At least it really looks like it, and I believe this to be a board that came from Apple, and not a board that came from some other form of independent repair. I think Apple's using liquid damage boards. I really do. So feel free to let me know in the comments what you think about that. I mean, this thing looks like crap even on the bottom. I mean, this looks like total crap. It's got these chunks and crap all over it. It's disgusting. We got dust and debris all under these, and I believe this to be a board that came directly from Apple. I'm really curious to hear what everybody has to say about that. This is at least the second one that I've ran into, maybe the third one. And I'm excited to be able to show this because the last times that I ran into this, I was just totally swamped, and I couldn't deal with it. So, without hooking anything else up to this board, we can look at this row of caps here from left to right, right across here. Do you see anybody that looks different? Look at that steaming pile of horse turd. That is a nasty looking cap right there. So now what we're going to do, I am going to open up a copy of EasyDraw here, which, by the way, the links for all of my tools and pretty much everything that I'm using is in the description below. Now, I've already decided that I have found the shorted cap because it's just blatantly discolored. Maybe that's because of liquid damage, or maybe it's because I already squirted 6 amps through it for a little while. Here we are. We've got EasyDraw opened up. Okay, we are going to open up the Qualcomm version of the iPhone. What is this, an iPhone 7? Gosh, what else would it be? And what is that, a 188 or 18? Okay, brain fart. I'm recording a video. I lose all capability of thought. All right, so let's zoom in down here at the bottom of the board, and let's look at that row of caps. Okay, now back under the microscope, we decided from the right-hand side it would be the first cap over to the left. So here we are on screen capture, and if we look at the first cap over here to the left, that's some sort of an arc boost something or other. That is not VDD main. Wow, look at me try to sound smart, and I look like a dumbass. Okay, so let's go ahead and turn the meter on. What I'm going to do, I'm going to go ahead and check that cap for continuity to ground. Okay, so if we check that cap to ground, we are absolutely getting 0. Wait a minute, what's going on? Did I twitch? Okay, so that cap is getting 0 ohms to ground on both sides. It is obviously shorted. I mean, I'm not imagining that. Tell you what, let's make sure that we're on the right board. Okay, so back under the microscope. Gosh, this thing just looks terrible. It looks like it's went through a washing machine or something, right? Okay. And we can read the number right up here on the board. This one is a 189, right there on the end, 189. So back over to screen capture. We did open up the 188. I mean, maybe on the 189 that cap is actually a VCC main cap. Now, I have learned somewhat the hard way that you have to be very careful, because sometimes the differences between these two boards is just a tiny little bit minute. Other times the differences between these boards is like really get you, and that's like down here at the backlight portion of the board. I'm not going to go into any details of that, but I'm just going to say that it's really important to make sure you're looking at the correct board, because sometimes the caps are reversed and sometimes it's literally the opposite of what you're testing for. So be careful to look at the right board. Now that we have the right board opened up, let's go ahead. We're going to zoom in. Now this is the board that does not have this stuff labeled. We're missing some information here. But if we click on that cap, we can see that it is still part of this chip here. Let's zoom out and see where else we have that. Okay, so this is going to be the correct line. I'm going to go ahead and open up the board that we have all the information on here, even though it is the incorrect board. And I tell you what we're going to do. Let's go ahead. I am going to look at a schematic here. So what we're going to do here on Easy Draw, we're going to do double open graph, and I'm going to pick the iPhone 7 bitmap. Now what this is going to do, this is going to open up the iPhone 7 board view and the iPhone 7 PCB schematic side by side. Okay, there we go. Now let's zoom in and see what that line is. So for this looks to me like another line that's going to be powered as soon as we hook up power. So when troubleshooting this board, you know, I guess I got all wrapped up in the fact that this looks like a liquid damage board straight from the Apple Store, that I didn't go into my initial troubleshooting on this. When the board first came in, the phone first came in, I hooked up a DC power supply to it and it immediately maxed out my supply, which is what you would normally see for a VDD main short. And this is, maybe this does have a VD main short, but it's also got an arc boost short too. Let's go ahead and check VDD main for a short to ground. So to check VDD main for a short to ground, we're going to zoom out and we're going to pick VDD main here. There's all kinds of places to get VDD main, but I always wind up being more in favor of, I always go for this spot right here. And I'll tell you, the other day I did one, I put my power here and it actually wound up being C3209. I was like, whoa, bonus, sweet. So here we are at VDD main. What I'm going to do here, I'm going to put my black probe on ground and I'm going to put my red probe on VDD main. Okay, let's do that again, only let's put the numbers in a place where you could read it. So black probe on ground, red probe on VDD main, and we're getting like 2800 ohms, 2.8K. So that is plenty of resistance for VDD main. So let's go back to what I said that I was going to do, and we're going to have a look at the schematic and see what we can figure out on this arc boost line. This is the first time I've ever ran into a short there, okay? So let's get back down here and let's look at this arc boost line. Yeah, so we've got, you know, VDD mains on either side here, but where we have a short is right here, and we know we know this line shorted. We actually know which capacitor it is, so I can probably just take a stab at it and remove it. But I'm curious, like, this is another line that I didn't know would cause us an immediate short. I didn't know that, and what I mean by that, let me get the power supply on the screen, okay? So there we've got the power supply on the screen. If I take this board laying right here on the table and I connect 4 volts to the battery rail, all I'm doing is plugging in a battery connector here that's got 4 volts running through it. If I plug that in, we jump straight to 3 amps. Do you see that? That's all we need to do. So this line must be powered, right? Of course it is, because we checked and we don't have a short on VDD main. It could be a short somewhere else. Okay, so let's look at this arc driver here. We know that we have a short right here along this this row here, and we're pretty sure we know exactly which cap it is. It's actually most likely going to be in this string of caps here. So we pretty much know exactly which cap it is, but what I didn't know is that this would provide us a path to ground even whenever this chip was not turned on. Is the chip on all the time? Well, you know, to be completely honest, I don't know exactly what is going on inside this chip, but I've got a sneaky feeling that our high current consumption, whenever power is applied to the battery rail, is going to be absolutely pertaining to the shorted capacitor we have here. So let's go ahead and remove this capacitor from the board. To do that, I'm going to use hot air and tweezers. Going to add a little bit of flux, which probably isn't necessary yet. We can just see that cap is broken in half, like long ways. It's really, really, really bad. Interesting. I did not know a short on this line would cause such a heavy current consumption. How is that? I don't really understand. I'm almost tempted to hook voltage up to it just to follow the heat trail, but I think for the sake of being nice to this phone and giving it a good repair here, I'm not gonna use it as a guinea pig right now. Let's go ahead and remove that cap. I've turned my air up a little bit because my last job was an iPad mini digitizer connector. Okay, off the board, nice and pretty. Now, while this board's hot, I'm going to go ahead and shine up these pads here. Flood some flux down there. It's easy to tell which side's ground. Goodness. We're going to call that good enough here. Now, I don't actually have a 10 microfarad 10 volt cap here in my arsenal. I'm going to grab another iPhone 7 board here. You know what? That looks like pretty much the same circuit on the 7 Plus, right? We're going to grab this one right here. You know, hopefully in the process of heating all this up, Trinity doesn't fall off the board on the other side, right? Follow the right white rabbit Neo. Trinity. We got Homer and Maggie. I don't know how you can have Homer and Maggie without Bart and Lisa. But then you got Trinity. It's like these Apple engineers, they're total movie heads. Alright, so let's go ahead and put this new cap on the board. We're going to drop this down into place, and then I'm going to go ahead and take a resistance mode measurement to ground here and make sure that we did get that short. Almost there. Oh, you crooked little... You are going to make my OCD flare up today. Let's see if we can make that solder melt a little better onto the ground side of that. Guess what we're going to do? We're going to leave it this time. Because I need to get paid. With a P. And if I nitpick it, I'm going to bump something next to it. I'm going to flatten Trinity onto the board on the other side. There's so many things that can go wrong here. Okay, so we have replaced that cap, and it looks equally as reworked as it did whenever it came straight from Apple. So I'm going to put my black probe on ground, and I'm going to put my red probe on that line to see if we still have a short to ground. And we do not. We have plenty of resistance to ground, which means we're no longer getting a straight shot to ground, which means I learned something today. I did not know that a short on, what was it, pp_arc1_v boost, I did not know that that line was hot, like as soon as you connect power to it. Let's see. Let's hook the battery back up, hook power back up to the battery rail and see if this thing still draws a heavy load just the way it is. So I'm going to use that camera right there for it. Let's get this thing out of parallel mode also. I need to learn how to record videos, guys. I've got my stuff configured wrong, so that is not currently updating. There, it's updating. Okay, so now let's hook our power back up to this, and let's see if we still get a heavy load. No, okay. So now we've got We've got our power hooked up and we're not drawing any current whatsoever. Now for the moment of truth. How am I going to do this? Me? Oh yeah, like my shirt? My wife made this one for me. She had her friend back in Missouri make it and send it to me. Love the shirt. Alright guys, let's use the customer's... Actually, I'm pretty well convinced that this is going... Should I clean it? You know what? Let's cross that bridge later. For now, let's just test this board and see if it boots. I am going to use the customer's housing. I'm really uneasy about the amount of crud on the bottom of this board. And there's not any fingerprints inside this thing. This phone looks excellent. It does not have the look of a liquid damage board. Not even the stickers look bad. It is not until I peeled the stickers off of the board that I realized that this looked like complete total garbage. Now I'm going to go ahead, let's go ahead and hook up these other things. Okay, let's hook up this. Hook up that. We're going to hook up our front camera flex. I guess I could always give it the taste test. Stick my tongue in between all those caps and lick up all around the PMIC and see if I could identify the mystery substance. I probably better just not do that though. Alright, now I'm going to go ahead, I'm going to hook the customer's battery back up to it. I'll leave the antennas unhooked. And now I'm going to plug in a lightning cable and see if I'm patient enough to wait for this phone to boot. Hey, I don't have to be patient today because we get an Apple freaking logo right as it boots. Let's let it boot up. Dun, 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 dun. Let's take the power supply off the screen. We're not using that. If I take it off the screen, I'll remember to not cover the window up with another window so that Open Broadcaster will actually update it, and I won't have to fight with my gear to record these videos for you. So, hey, zoom enabled. Let's move it slightly. Okay, straight to a passcode screen. And it also vibrated. Just in case I have to clip that part out, it also vibrated. So this is a vibrating phone, and it's up and running. I didn't have any lengthy boot. I didn't have anything crazy going wrong there. Well guys, I'm going to try to keep this video as short as I can. So just to recap here, if you have a short on this line here, it will consume power the very moment that the battery is connected. Now, I'm sure that there's lots of you out there that already knew that. I didn't know that. I learned something new today. I learned that mini boards directly from Apple look like complete total dog shit, and I also learned that a short on this ARC1 V-Boost line will cause a symptom that is similar to a short on VDD main. So guys, that's it for this video. I sure thank you for watching. Thank you for subscribing. If you like this video, please click the thumbs up button. That means a lot to me. And is there anything else? No. I'll see you next time. Have a good day.